The team of Jared Gibbons, Jared is a senior at Wheaton Warrenville South. He enjoys DJing and mixing music, and then experimenting with cooking and food, and communing with nature. He's currently considering either Waubonsie Community College or COD with an expectation of a 4-year degree to follow in audio engineering. We also have Kyle Lacer. He's a senior at Wheaton North. He's into gaming and working in the renovation industry. College of DuPage is in his plans. He plans to transfer to Savannah College of Art and Design after his COD experience. Then we have Jacob Gibbons. He's a senior at Wheaton Warrenville South. He is into DJing and mixing music as well, and also into personal fitness. He's currently considering either Waubonsie Community College or COD with an expectation at the end of it all of a 4-year degree in audio engineering. I think you're going to enjoy this one. All of these have had products that we can use. This one, we can use a lot. So I'm going to turn it over to these guys, and they're going to introduce you to Crack a Snack.
Today we'd like to introduce to you guys the Crack a Snack, an innovative design for the potato crisp can. Just to raise your hands, how many people have the issue of not being able to fit your hand into a Pringles can, for example? Alright. I would just like to demonstrate the problem that I have with it. Not being able to get in there, and you can. One shift there. As I'm sure we've all faced that problem before, getting our hands stuck in that can, breaking chips, and then no longer having an enjoyable snack, we should easily be able to access the chips that we want so badly. A couple months ago, we had mentors from several companies come in and visit our classroom, and they also allowed us to present our ideas to them. They gave us a lot of helpful feedback and a lot of ideas for our product. Also, the senior editor of Cooks Illustrated, Dan Souza, as quoted, "I've been unable to fit my hand inside the tube, and I know I'm not the only one with this problem." This was discussed on one of his blogs along with thousands of other people, and this is not the only blog discussing this problem either. Now I'd like to pass the mic over real quick to my partner Jared to explain the statistics.
We surveyed a group of 25 people and asked them questions such as, do you enjoy potato crisps, such as Pringles or the Lay's stacks? And we asked them, how often do you encounter this problem of getting your hand stuck in the can and just ruining the experience of your chips? And a lot of people answered it was almost every time or often. We also asked them, how much would you pay for a container such as this? And it ranged from answers from $3 to $8.
Similar solutions that we came across while we were researching was right here. This is a linear chip dispenser, and as you can see, there's a handle that you push, and it's almost similar to a push pop. The next similar solution we found was a bingo chip dispenser, and on top there is a little handle that you press down and it dispenses the chips out. The problem that we had with this solution is that the chips would break while coming out through this guard. And the last similar solution we found was a chip dispensing container, which had a circular ridge on the outside that you twisted down, while one on the inside rose and brought the chips up. The problems that we had with that design and the first one were that they really didn't get rid of the problem that you had to use your hands.
During our research and idea generating, we asked ourselves, what materials would be the most durable and cost efficient in our product, and how can we make the product appeal to everyone? Not just the average potato crisp lovers, but sports fans and everybody who enjoys chips. Possible solutions that we generated at first during brainstorming. As seen in the top left, we had a can that going down, there were sections, and you could take them apart using interlocking teeth. and we just found that one to be unuseful because it still had the problem of using your hands. We also had another idea in the top right. There's a can with a perforated line that twists down almost similar to a Pillsbury cinnamon roll container. And once again, that's just a problem that it's still a lot of work and could be messy potentially. Our third idea we came up with is a hand that attaches to the original Pringles can and has a knob on the side that you can set how many chips it grabs for you from the can. And our last and final one that we generated, which is the final design we went for with our product, is similar to a lunchbox with a latch on the front that you can open and set out for groups so that many people can access the chips for events such as game day or parties. Our solutions considered, this is a similar solution matrix comparing the 3 previous designs we had before we generated. And the criteria that we compared to our designs were simple, easy to use, fun, safe, easy to clean, easy to store, does not cost a lot, and it performs well. It does what it's supposed to do. And as you can see, none of those designs met all the criteria that we needed. For our prototype process, we used PVC piping and super glue along with cardboard. We took a PVC pipe down to the construction area and had the instructor down there cut it in half for us. And then we then took 2 halves of a cardboard circle and put them on each side just to cover the edges and ensure freshness in the prototype. In our finished prototype, we used tape for a hinge just as a substitute, just for a quick observation.
As you can see here, this is an image of the multi-view for our final product, which we created on a program called Autodesk Inventor. It's just a 3D modeling software, and yeah, so this is what we have here. On the left, you can see is the top of the can, which we had to make the parts separately just because of the size that we were able to print out in the 3D printer. And then on the right is our bottom. In the picture, it shows, I mean, if you can see it, it's right here. In our design, we flattened the bottom of our second half, just so when you close the container or you have it open or however, it makes it so it doesn't roll away.
As you can see here, this is the final design that we printed off the 3D printer. And while it looks very nice, it's something that when it comes to mass production is something that's going to be needed. Because when it came to the 3D printer, it came down to $5 per cubic inch. So overall, just this one model costs $35 to make. So it's not something you really product to a lot of people. But in the future, it means that mass production, it'll be a lot cheaper because I can guarantee a softer, cheaper plastic will be used as compared to the ABS P430.
Some design issues that we had with this is when printing with the 3D printer, there's excess plastic because it has to print on an X scale and then a Y scale. And so when we had that problem when printing the hinge, because we had to scale it down to size so it would be able to print on the 3D printer, the excess plastic would get into the hole for the hinge, and making it very difficult to remove that excess plastic. We've tried multiple ways of removing it. We tried drilling through it, which ended up breaking the hinge. We tried taking a nail and like hammering it through as gently as we could, but that also broke it. And we just need to scale it to size, and it would be a lot easier to remove that. Because of that, when we first started like chiseling away at it and everything like that, our latch on the front broke easily because of the way we were removing it. So we had to put it into a solution that would slowly dissolve away the excess plastic. Our stress test, we put it through a stress analyzer with Miss Johnson helped us with. And what I found very interesting was when we put it in there on a horizontal plane, when we tested it, it was able to withstand 70 pounds of force, which is really cool in my opinion, because if you were to have this on your bed and you had your chips in there, or you were to roll over on it, something like that, it wouldn't do anything. Even a small child could step on it and it wouldn't damage your chips. And on the vertical, it was able to withstand 500 pounds of pressure, which was also very interesting, just showing how strong the plastic was. Our next steps is we would like to make it like customizable to the people that were to buy it, where on the front of it, or the whole thing of it exactly, is you'd be able to put your own personalized decals. You could put your name on it, or you could have the emblem of your favorite sports team, or just any picture that you'd like. It'd be customizable to the consumer. Our acknowledgements are to our teachers, Mr. Kinzik, Mrs. Johnson, Mr. Carr. We'd like to thank you for all of your input. I'm sorry, I don't know how to say her name. But we'd also like to thank you for your input, and same with Mrs. Shackelford. We'd just like to thank all of the staff and the students that participated in our study, taking our survey, and we'd like to thank our parents for their constant support throughout our project. And then here's just our works cited from the sites we use, like Google Patents and the Food Critics site.
I have a comment. You guys did a fantastic job. I mean, you guys followed. All the presenters did a great job. But this is an excellent example of using scientific method. I mean, you guys created a log. You put all your results in there, your initial designs. You did stress tests on it. You captured and documented everything. And it's really the essence of what scientific method is. You keep trying, you fail, and you keep trying. But your documentation shows the path that you took. You know, I looked at this when we were walking around before, and it looked so simple, but it's not, is it? If you guys don't have a career in engineering, you have a great career in marketing. So you guys did a great presentation.
Thank you.
Was the intent that the food manufacturer would provide this in order to sell it, or would this be something that would be sold separately so you can empty out a Pringles can into it?
Right now, the product itself would be sold as just the tube, but another marketing idea that we're having for future reference is eventually making our own potato crisp to sell with the product and having disposable versions and like a long-lasting one.
Because this thing would sell as a separate thing. You just empty the chips in there, seal it.
Yeah, right now you would just put the crisp in.
And I kept waiting for you guys to say, okay, how are you going to keep the chips from getting stale? Because one of the most important things for sealing food is the package has to protect the product, and it has to protect it from oxidation so it doesn't get stale. And you covered it at the very end. So if you saw me make a move like this, that was because you finally hit it. And the other thing is, if you are serious about following up in a career in this, Michigan State offers a degree in packaging science. And it's a very big field to get into it. Every food company will want it. So.
Thank you. I would just like to mention, in the next step slide, I forgot to say, is that one of our next steps was actually to add a seal. We were just trying to make it so it was airtight and then it wouldn't potentially stale your chips. Any more questions?
What would be the easiest way? Because, okay, first off, I didn't even realize I had that problem until you guys brought it up. Now I can't stop thinking about it. But usually, you know, you're pouring out the chips. How would you be able to do it without breaking in what you're putting into this container?
Well, our original idea is that they just tilt the can, angle it, and slide it into it. Because normally we'd have like a party serving or just like a game day or something like that. And when it came to the production in the future, if it came down to it, we actually hope to sell the idea with a company and have them find a cheaper way to mass produce it, and we could work along with them.
I love that you did a stress test. I'm wondering, did you do a stress test on the existing container?
We did not, but just because it was cardboard, I've had the problem where I rolled on it before and it broke all my chips.
It would be nice to have that comparison though.
Yeah, I would
You
add.
can say, hey, we got 70 pounds stress test versus 2, or whatever it is.
Thank you.
If you're gonna go forward with this, what would be the biggest hurdle you would see in the design?
I think a big hurdle for it would be convincing them to change the container. Basically, is just saying like they're so used to having this really cheap container, which isn't really really like strong or fun to have exactly. So just showing them how fun it can be to have this new idea and just getting them to go along with it would be our biggest hurdle, I guess.
And I also feel like another hurdle that we would eventually have to face would be if we did sell the idea to a company. I feel like it would be hard to stick with our idea for the custom products and like the decals, because if a company had to mass produce it, it'd be hard to have a separate line and like area of the company. Just it's almost like a new whole section where you have to get workers who are specialized in that and just can work efficiently to get all that done.
Put your hands together for you guys.